Okay, we're going to go ahead and start section 3.1, which is all about the radian measure. Okay, now when we talk about algebra in general, what we have done, or well, what we do in algebra is we're studying properties, right, of numbers. We're setting up these relationships, which a lot of times we call x and y, so that we can graph it on a rectangular coordinate system, right? We can graph it and there be a relationship between x, our input, and y, our output, right? Now, so far, for our trig class, we have thought of the theta angle being our input value, right? We discussed an xy point that's on the terminal side of that angle, but we've mainly focused on a ratio of the side lengths, right, of that triangle created by that angle. So now what we want to do is we want to introduce a different unit, and that's what we're going to explain in this section, and kind of describe how it's related to degrees so that we can move between radians and degrees. And what this is going to do is help us move to an x input, y output type curve, and that's kind of where we're headed. That's what we're going to get to in chapter 4. But for right now, we can do a lot of other things with these angle measures if we can write them in radian form. Okay, so here's our definition of how we describe radian measure. Okay, this is an angle with its vertex at the center of a circle. So you can kind of, I don't know if you can see, mine did not copy very well. So I'm going to go ahead and just kind of go over this. Hopefully your paper printed out nicer. Okay, so hopefully you can kind of see that circle a little bit better. So our definition here says that radian measure, we're talking about an angle with its vertex at the center of a circle. So you can see here it's at the center, that intercepts an arc on the circle equal in length to the radius of the circle, has a measure of 1 radian. Okay, so what that's talking about is that our radius, right, of this circle is equal to the arc length created by that angle. So that and this are equal lengths. Okay, when that's true, this is considered 1 radian measure. Okay, so let me tie it back to something maybe you can remember from yesteryear. Okay, remember whenever we talked about the circumference of a circle, right? Remember, circumference is the distance all the way around the perimeter. Okay, I'm going to write that. Circumference. The circumference of a circle is 2 pi r, right? So if we talk about going all the way around the circle, we're talking about 1 full rotation. Okay, 1 full rotation is 360 degrees. Okay, so our degrees, 360 degrees, is the same as 2 pi r. Now this r stands for radians. So we can say 360 degrees is the same thing as 2 pi radians. So now we know where that comes from. Right? Now, this is a very important relationship that we need to know so that we can convert between degrees and radians. But it's not the most simple form. It's not the simplest form of this relationship. Because if you look at both sides of the equation, actually can be reduced, right? 360 has a factor of 2, and 2 pi radians has a factor of 2. So if I were to divide both sides by 2, what I would end up with is 180 degrees is equal to 1, or just pi radians. Okay, so this is our big important relationship that we want to be able to walk away from in this section. Okay, so if we scroll down here, I say scroll down, if I push my paper up so you can see all of it, this is really just describing the relationship between degrees and radians. As one sweeps out 360 degrees, okay, one full rotation, one sweeps out 2 pi arcs, each of length equal to the radius, right? Thus, one sweeps out 2 pi angles of measure 1 radian. So this is basically what I worked out at the top of the paper. We can say that one full rotation, or 360 degrees, is the same as 2 pi radians. And then we can reduce or divide both sides by 2 to get 180 degrees is equal to pi radians, right? Now, if I were to take this equation, I could divide both sides by 180, and I would end up with this equation, right? Because if I divide the left-hand side by 180, I would get 1. And if I divide pi radians by 180, I would get pi radians over 180 degrees, right? The same thing is true as if I divided off the pi radians. If I divided by pi radians on both sides, on the left-hand side, I would have 180 degrees divided by 2 pi radians. And on the right-hand side, pi radians divided by pi radians gives me 1. So these are the two ratios basically that we are going to use, okay, two ratios to know, okay, because this is the relationship we're going to use to be able to convert things from degrees to radians or radians to degrees, okay. This other part just kind of explains where it comes from. Now, before we get into converting from degrees to radians or radians to degrees, I want to take the unit circle. Remember the circle that we've talked about doing a 30, 60, 90 triangle with, you know, and we've dealt with different angles. I want to be able to write those angle measures in radians. So that's what we're going to do on the other side of this paper, and then we'll look at converting between the two, okay? So I try to do this in the order that makes the most sense, and we'll see how that goes, okay? All right, so the first thing I want to do is start off with what we just learned, right? We know that a full rotation, I'm just going to write it up here. A full rotation is 2 pi. So if I start at 0 and I go all the way around this circle and end up back at 0, right? That's a full rotation. That's going to be 2 pi. So I'm just going to write off to the side here, 2 pi, okay? When we talk about a 0, let me see if I can make this higher so I can zoom out a little bit more. Maybe. All right. So if I go all the way around the circle, that's 2 pi, right? So then let's just think about a half rotation, okay? If we do a half rotation, that would only be to 180 degrees, right? That would just be to here. That's a half rotation. And half of 2 pi would just be pi, right? So 180 degrees we could label as pi, right? All right, so we have our x-axis labeled. Now let's look at our y-axis, okay? So let's keep going with this. So we started with a full rotation, then we broke it down into a half rotation. Now let's look at quarter rotations, or 1/4 rotation, okay? So in other words, what I'm talking about is going up here to 90 degrees, okay? That's a quarter of a way around the circle. So let's think of it in terms of this half rotation. So if I go to 180 degrees, that's pi, right? Pi radians. So if I want to only go half that value, if I want to only go to 90 degrees, half of pi, right? We could write it as 1/2 of pi. We can just write that as pi over 2. So a quarter rotation is pi over 2. So I'm going to go ahead and put that up here, pi over 2. Okay, so every time we go a quarter rotation, we're basically adding a pi over 2. So let me see if I can get the whole circle in my screen. I can't. Okay, so we're going to start here. We're at 0. When we get to 90, that's 1 pi over 2. Then we come over here, this is 2 pi over 2, right, if we count by pi over 2's. So 90 degrees is 1 pi over 2. 180 is 2 pi over 2, which then just reduces back down to pi, right? And then if we go down here to our 3/4 rotation, that's going to be 3 pi over 2, right? So let me scoot that up here. 3 pi over 2. And then I could keep going. If I head back up here to 0, another pi over 2 rotation is going to give me 4 pi over 2, right? Which again, that just reduces down to 2 pi. So all of these quadrantal angles I can get to by counting by a pi over 2, right? 1 pi over 2, 2 pi over 2's, which is just pi, 3 pi over 2, and then back to 4 pi over 2, which is 2, okay? So that gives me all my quadrantal angles. Now let's look at coming up with our other angles, our 30, 60, 90 degree angles, and all their corresponding ones, okay? So let's look at 30 degrees. If I look at 30 degrees, I'm going to look at it just in this first quadrant, right? Because we have this nice angle labeled for us at 30 degrees. So what I want to do is, since I already know what 90 degrees is, I want to try and figure out what fraction of 30 degrees or what fraction of 90 degrees is 30 degrees, okay? Or in other words, 30 degrees is what fraction of 90 degrees, okay? 30 degrees is what fraction of 90 degrees. Well, we can see here that if we go up to 30, right, 30 out of the 90 degrees, that's a third of the way, right? So 30 degrees is a third of the way to 90 degrees, or a third of the way to pi over 2, right? So I'm going to go ahead and say this is 1/3, right? 30 degrees is what fraction of 90? It's 1/3 of the way. So 30 degrees is 1/3 of 90 degrees, right? Or 1/3 of, instead of writing it as 90 degrees, we could say pi over 2. Pi over 2. And then if I calculate this, 1/3 of pi over 2, I just multiply straight across. This gives me pi over 6. Okay, so I can relabel 30 degrees as pi over 6. Okay, so this is how I came up with this one. Okay, so now that I know what 30 degrees is, I know that one 30-degree angle is the same distance as pi over 6. It's a pi over 6 measure. I could go ahead and count by pi over 6 now, and go in 30-degree rotations all the way around this unit circle. Okay, so let's do that. If we start here, and we know that this is, here, I'm going to write it right in here. Let's say this is pi over 6. Okay, this is the one we're starting on. If I go another 30 degrees, right, I'm going to land here at 60. So this was 1 pi over 6. This is going to give me 2 pi over 6. Right? Now 2 pi over 6 actually reduces, right? I can reduce the 2 and the 6, and I'll just be left with pi over 3. So that's how I can label this angle, pi over 3. Okay? And then I'm going to continue going 30 degrees at a time until I get all the way around the circle. So this was 1 pi over 6. This is 2 pi over 6. If I go another 30 degrees, this is going to be 3 pi over 6. And even though we already have this one labeled, it's a good way to check ourselves, right? 3 pi over 6 does reduce to pi over 2. Okay? And then we're going to go another pi over 6. So again, this was 1 pi over 6, 2 pi over 6, 3 pi over 6. This is going to be 4 pi over 6. And 4 pi over 6 reduces, right? 4 and 6 I can reduce by 2, and that's going to give me 2 pi over 3. 2 pi over 3, okay? Hopefully y'all are with me. So again, I'm going to go another 30 degrees. If you've got the hang of this, you can keep going all the way around the circle. Just make sure you reduce it before you write it out here. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is going to be 5 pi over 6. 5 pi over 6 does not reduce, so I'm just going to leave that as 5 pi over 6. And then I go another 30 degrees, which gives me 6 pi over 6. And again, we already have an answer for that one. We know that reduces down to pi. Okay, move my paper up so I can get these bottom angles. All right, so we're up to 6 pi over 6. So we go another 30 degrees. That brings us to 7 pi over 6. 7 pi over 6 does not reduce. So I'm going to go ahead and label this as 7 pi over 6. Then I go another 30 degrees, and that brings me to 8 pi over 6. Now 8 pi over 6 does reduce, right? I can reduce on top and bottom by 2, which leaves me with 4 pi over 3. Okay. And then I go another 30 degree measure, and we're up to 9 pi over 6. And 9 pi over 6, notice, reduces down to 3 pi over 2, which is what we have this 207 degree measure labeled as. Okay, so I keep going, we're almost there. I go another 30 degrees, and I add another pi over 6, so this brings me to 10 pi over 6. 10 pi over 6 reduces. I can reduce on top and bottom, that 10 and the 6, by 2, which gives me 5 pi over 3. Right. Then I bring it another 30 degrees and add another pi over 6, which gives me 11 pi over 6. 11 pi over 6 does not reduce, so I'm just going to leave that one as 11 pi over 6. And then if I add one more, notice I'm back to 0. So that would give me 12 pi over 6. 12 pi over 6, again, is just 2 pi. Okay? So all of these angles that have either a 30 or a 60 degree reference triangle, we can find by just starting with 30 degrees, changing it to radians, and then we can count by pi over 6 to find any of these 30 or 60 degree marks. Okay, so the only one that I have left to do is my 45 degree angles, right? So let's do it the same way we thought about 30 degrees. Okay, let's think about 45 in terms of 90 degrees. Okay, so what fraction of 90 degrees is 45 degrees? Right? So 45 is half of 90 degrees, right? 45 degrees is half of 90, right? But again, we're not writing 90 as 90 degrees, we're writing 90 as pi over 2, which means that 45 degrees is half of pi over 2. And then if we multiply straight across, that gives us pi over 4. So I can go ahead and label this 45 degree measure as pi over 4. Okay? Hopefully everybody's with me. And then now that I have a 45, remember your 45s are these that cut your quarters directly in half, right? I want to go around in 45 degree increments and label the rest of them. Okay, so again, we just determined that this one is pi over 4. Okay, so I'm going to go ahead and go to the next 45 degree measure. So that's going to take me to here, and that's going to give me, okay, remember we're counting by pi's over 4 now, so this is 1 pi over 4. This is going to be 2 pi over 4. And you can see that 2 pi over 4 and 2 pi over 4 reduces down to pi over 2, right? So far so good. We're going to go by another 45 degree. So this was pi over 4, 2 pi over 4. This is going to be 3 pi over 4. Now that doesn't reduce, so we're going to leave it just like that. 3 pi over 4. Okay? Then we go another 45 degree measure. So this one was 3 pi over 4, so this one's now going to be 4 pi over 4. We know that 4 pi over 4 reduces down to just pi. Right? Scoot this up. And I keep going. Another 45 degree measure brings us to 5 pi over 4. And that also doesn't reduce, so we're going to leave that as 5 pi over 4 to represent our 225 degree angle. Then I bring in another 45 degree measure by counting another pi over 4. So this brings us to 6 pi over 4. And 6 pi over 4, you can see, reduces to 3 pi over 2, which is what we have written down here, right? Okay, so I'm going to go one more 45 degree measure, which is another pi over 4. So that brings us to 7 pi over 4. That does not reduce, so that's what we're going to label the 315 degree measure as 7 pi over 4. And then our very last rotation takes us back up here. We add another pi over 4, which gives us 8 pi over 4. And 8 pi over 4, if we reduce that, becomes just 2 pi. Okay, so now I have, I wish I could zoom this all the way out. Let's see if I can get the whole circle. So now we have our whole circle labeled, right, in terms of pi. So these are our radian measures, okay? So I will tell you, for your next exam, you will need to be able to label a blank unit circle. So if I just have 0, 90, 180, you know, or whatever, you should be able to fill in with either the degree measures and also the radian measures. Okay, so I'm going to go ahead and just put down here, we call this the unit circle. Okay, and you need to be able to label the corresponding degree angle with its radian measure. Okay, put that where you can see it. Okay, so we want to be able to label the corresponding degree angle with its radian measure. So if I give you degrees, you should be able to give me radians. If I give you radians, you should be able to give me degrees. Okay, so now let's go ahead and look at converting some of these from degrees to radians or radians to degrees. Okay, we're going to do that on the next page. All right, so now when we're converting from one to the other, we're going to use these two ratios that we came up with on page 1. Okay, remember, degrees and pi radians is the same thing. So we just have to determine which ratio we need to use. Okay, so this one says convert the following angles in degrees to radians. Okay, so that means we want to end up with radians on top. So that means for this one, we're going to use the second ratio. And it's also easy to pick which one you need to use because it's going to be the one that cancels out your degrees. So I'm going to go ahead and multiply this by pi radians, and I'm going to abbreviate radians by RAD over 180 degrees. Okay, so what's going to happen when I do that is I multiply straight across. Notice my degrees will cancel, so I get 108 pi radians over 180. Now we want to make sure that this is as simplified as possible. Okay, let me see if I have a different pen. These ones are casting a really bad glare. I apologize. Maybe this will work better. Okay, so I want to introduce you to the good old fraction button on our calculator. If you're not familiar with this fraction button, it's a life changer. So when you turn your calculator on, you may have a button that looks like this one. Mine says A, B over C. You may have one that says X over Y or something like that. But this is a fraction button. And so you use it in place of like how you would use the divide. So if you want to do 1/2, you would do 1 and then hit your fraction button and then 2. And that will put it, you know, as a fraction, 1/2. So the way I'm going to use it is I'm actually going to enter this fraction, not the pi, but just the numbers, 108. Use my fraction button to make that the numerator. It's over 180. And when I hit enter, what it does is it reduces the fraction for me. Okay, so magical. So this reduces to 3/5, and then I still have that pi in there, right? So this is going to be 3 pi over 5 radians. Okay. All right. And then you might also, it might also ask for it in decimal radians. Okay. So this is how we express our answer with the pi left in it. If they want it as decimal radians, then we want to make sure that our calculator is in radian mode. Move that right here. Okay, so I'm going to clear this. Mine is right here, the DRG, that means degree. When I push that, you can see I can move over and select radians. Some of your calculators may have a button up here in this corner that says mode. So it's under the mode button that you can change it to radians. Again, but on this calculator, it's this DRG, the degree button. So make sure you move the arrow over to radians and hit enter. Right? And then we can go ahead and I can enter it as my solution here, excuse me, which is 3, and then I use the pi button. Don't approximate with 3.14. Okay, use the actual pi button on your calculator. So 3 pi over 5, and notice I use the division key because I don't want to get a fraction, right? If I would have entered this using the fraction button, it would have just given me 3 pi over 5 back. But I want to make sure it gives me a decimal, so I'm using the division button. And this comes out to approximately 1.88 radians. Okay. So just depending on what they ask you to round it to, I just wanted y'all to have a little experience calculating it both with a pi measure, pi radians, and then also as a decimal measure. Okay. All right. So what I would like for y'all to do is do the next 2 conversions here. Okay. So these 2 are going to be practice problems. So go ahead and pause the video and try to convert negative 135 degrees and 325.7 degrees to a radian measure, okay? And give me both answers. Give me your answer with pi radians, and also give me a decimal answer, okay? Whenever you're ready, go ahead and unpause it and we'll see how you did. Okay, so let's go ahead and see how you did. On the first one, or actually on both of them, you're going to use the ratio pi over 180 radians. And I forgot to write radians up here. Radians. Because we want our degrees to cancel, right? So this gives me negative 135 pi over 180 radians. Using the fraction button on your calculator, you can see this reduces down to negative 3 pi over 4 radians. Okay, and then if we wanted a decimal approximation versus a pi measure, then we can punch this into our calculator, which should give us negative 2.36 radians. Okay, same thing on the next one. Now this one, notice it already has a decimal. So if it already has a decimal, it's okay if you end up with a decimal even when you get your pi answer. because obviously when we multiply by pi over 180, these two, you're not going to be able to do this using your fraction button if that already has a decimal. So what I did is I went ahead and just divided the two numbers and just kind of approximated. So this becomes 1.8 pi radians, and then if we want it in a true decimal fashion here, then it's going to be 5.68 radians. Okay, so I always have people ask me, why do we even bother with the pi? You know, why don't we just punch it into our calculator and get it in radians? And the reason that I like to leave the pi is because it's actually a little bit easier to visualize, or a little bit easier to graph when you can visualize a distance of pi, because now we're used to the idea of pi being 180 degrees or half a rotation, right? So this is 1.8 half rotations. Does that make sense? Okay, and we'll get into that more in unit or in chapter 4. All right, so now let's look at going the other direction. On all of these, we went from degrees to radians. Now let's see if we can convert from radians to degrees. So on these, we're looking for which ratio, right? If we want to end up with a degree measure, then that's what we want on top. So for these problems, we're going to be using the 180 degrees over pi radians, okay? So we're going from 11 pi radians over 12. We're going to multiply by 180 degrees over pi radians. And notice what happens is our radians are going to cancel, right? Radians cancel. And also our pi's are going to cancel, right? So when we multiply straight across, we're getting 11 times 180 degrees all over 12. Now again, you can go ahead and do all of this in your calculator real quickly if that is your easiest method here. 11 times 180 and then divide it by 12, and that gives us 165. So we end up with 165 degrees. Okay, don't forget that degree in there. Okay. All right, so I want y'all to try B and C again as practice problems. Let's go ahead and pause the video, try those out, and then we'll go over them when you unpause, okay? Okay, so let's see how you did. On part B, we're going to multiply by 180 degrees over pi radians. And notice here our radians cancel and also our pi's cancel. So that leaves us with just -7 times 180 on top, 6 on the bottom. And when we simplify that, it gives us -210 degrees. Okay, let's look at part C. Part C, notice we started with a decimal, so we may end up with a decimal answer. Okay, just pay attention in your homework how it wants you to round your answer, or if it asks for significant digits, okay? If it asks for significant digits, then here we would only have 3, right? The 2, the 9, and the 2 is what we're starting with, so that's how our answer would be. All right, so again, we still work it as 180 degrees over pi radians. Notice again my radians cancel, but notice I don't have a pi that cancels, right? This one came out to where we didn't have a pi, and that happens sometimes. So when I multiply what's left over, I have the -2.92 times 180 on top, and on bottom I still have that pi. So what I did is I went ahead and just got a decimal for the top, and then I divided it by pi. Again, make sure you're using the pi button on your calculator and not approximating with 3.14. Okay, you want all the decimals of pi in there. So that comes out to -167.30 and a bunch of other things. Again, I just went off of significant digits. Since what was given to me had 3 significant digits, I just took 3 significant digits in my answer. But make sure you pay attention on your homework, because it may actually say round to the nearest 100th or 10th, or it may ask you to use significant digits, okay? All right, so now I feel like we are super capable of converting from radians to degrees or degrees to radians. Why would we want to do that? Well, let's look at these last few problems on page 4. It says, note if the unit of the angle isn't given, one should assume that it's given in radians, okay? So if there's nothing said, we assume that it's given in radians, okay? All right, so what we want to do is we want to find each trig function value here, okay? And we haven't really done a lot with these radian measures, right? We've only used the reference triangles to find out the trig function values. So what I'm going to do first is, in order to find a trig function value, I first need to know what degrees we're talking about. So I'm going to go ahead and just write here, first convert to degrees, okay? Because then I know how to draw my reference triangle. So here we have cosine of 5 pi over 6. So I'm going to go ahead, I'm just going to keep writing it the way it is. Cosine 5 pi over 6. Now I want to end up with degrees, right? So I'm going to do 180 degrees on top. So I'm going to do 180 over pi. Now the reason I didn't write the word radians is because we're already assuming that this measure is in radians. So if you want to write radians after this one and write radians down here so that you can cancel them, that's totally fine. Or you can leave it off on both, right? Okay, so I'm going to go ahead and notice that my pi's are going to cancel, right? And then I can do 5 times 180 and divide it by 6 on my calculator. So when I do 5 times 180, because that's what I have left on top, and then I divide that by 6, I end up with 150. So what we really have is cosine of 150 degrees, okay? So I should be able to figure this out, right? I should be able to figure this out. So let's figure out where 150 degrees is. If I think about my reference triangle, okay, this is 180 and this is 90, so I know it's going to be over here in quadrant 2, and 150 is 30 degrees shy of getting to 180, right? So I'm going to go ahead and draw, this is my 150, right, and it's a 30 degree angle here, because it's 30 degrees shy of getting to 180, right? And then we should be able to label this, because we know our 30, 60, 90 degree triangle like the back of our hand, right? Opposite the 30 is a 1, and then opposite the 90 degree angle is a 2, and then opposite the 60 side would be square root of 3, right? Now, because it's in quadrant 2, I need to think about my signs. Notice my opposite side is above the x-axis, or sorry, above the x-axis, so it's a positive 1. But my square root of 3, notice it's to the left of my y-axis, so this is actually going to be a negative square root of 3. And then we know our hypotenuse is always positive, so that 2 is going to be positive. Okay, so I just need to calculate the cosine of 150. We know that cosine is adjacent over hypotenuse, right? So here, if I do the adjacent side, that gives me negative square root of 3 over my hypotenuse, which is 2. Okay? So I just want to point out, everything that I did from this little triangle over is not new, right? This is something we've already done. We know how to find the reference triangle, we know how to label it, we know how to determine if our opposite and adjacent side should be positive or negative, and we know how to find the cosine by doing adjacent over hypotenuse. So the only new thing here was first converting the radian measures to degrees so that we could do all of that. Okay? All right, I'm going to give you the opportunity to go ahead and pause the video. I really encourage you to try to do B or C by yourself, if even if the only thing that you get through is getting the degree measure. Okay, but go ahead and try those two, and then when you're ready to check yourself, or if you get stuck, unpause it and we'll go through them. Okay, but I'm going to go ahead and put B and C as practice problems. So give those a go, and then when you're ready, we'll go over them. Okay, let's see how you did. So on the first one, we have cotangent. Okay, before we can do anything with cotangent, we need to first make our radian measure into a degree measure angle. So we're going to multiply by 180 degrees over pi. My pi's will cancel, and when I do 3 times 180 divided by 4, that leaves me with 135. So I'm calculating cotangent of 135 degrees. So if I draw a 135 degree angle, that again is going to put me into the second quadrant. 135 is exactly 45 degrees from hitting the 180 mark, right? So it's 45 degrees shy of getting to 180. So I know that this is going to be a 45 degree reference triangle. So I should be able to label both the opposite and adjacent sides with a 1 and my hypotenuse with a square root of 2, right? Now we know this side, this 1 that's over here, because it's to the left of the y-axis, we know it's a -1. Because the opposite side is above the x-axis, we know it's positive. Okay, so now that we correctly have labeled our reference triangle, now we can go ahead and calculate cotangent. Cotangent is the inverse, or not the inverse, sorry, the reciprocal of tangent. Tangent is TOA, opposite over adjacent. So the reciprocal of that would be adjacent over opposite. So I'm looking at my adjacent side, which is -1, over my opposite side, which is +1. And -1 over +1 gives me -1, right? So hopefully that one wasn't too bad for you. We're going to do the same thing with secant. Okay, we can recall that secant is the reciprocal value of cosine. Okay, so we can either find the cosine and then flip it, or we can just flip the way that we solve for it, right? Cosine is adjacent over hypotenuse. So if we're looking for secant, we're going to do hypotenuse over adjacent. Now, before we can do any of that, we have to change this into a degree measure. So we're going to multiply by 180 degrees over pi. Okay, now I'm going to stop here for just a second. Okay, let me cover up the answer. If you struggled on part B, I encourage you to try to go ahead and pause the video and try to work this one out by yourself, just so that you get some practice working through an entire problem by yourself. Okay, if you work these all on your own, then go ahead and keep listening. All right, so my pi's are going to cancel, and I do 5 times 180 degrees divided by 3, which gives me 300 as my angle measure. So a 300 degree angle looks something like this. It's 60 degrees shy of getting back to a full rotation, right? Because 360 is a full rotation. So if I go 300, I'm 60 degrees shy of hitting that full rotation. So again, I'm going to label this as a 30, 60, 90 degree triangle. Opposite the 60 is the square root of 3. We know the hypotenuse is the longest length, which is 2, and that leaves 1 for the other side opposite this 30 degree angle. Okay. And then when we label these, we can see that 1 is up here in quadrant 1. So it's going to be positive, right? Or not quadrant 1, to the right of the y-axis, so it's positive. My square root of 3 is below the x-axis, so it's going to be negative, and our hypotenuse is always positive. Okay, and then we talked about over here, in order to calculate the secant value, we do hypotenuse over adjacent. So our hypotenuse in this case is 2, and our adjacent side is 1, and 2 over 1 gives us 2. Okay. All right, so that is the end of section 3.1. So you should now be able to complete that assignment in my math lab. If you have questions, please let me know. I'm happy to help.